This talk, I think, can be viewed really as an independent audit of the IPPC. I don't have any skin in the game. All I care about personally is that good science needs to be done. I'm auditing the IPPC and its contributors. There are many. They're both their arithmetic, their scientific methodology regarding their claims of global warming, climate change, and impending climate crisis. It appears from my audit that they have dishonestly cooked the books, fudged the data, and rigged the conclusions. So as to claim they have proven the existence of global warming and climate change. It also shows that Al Gore's reporting that there is total scientific consensus among climate science researchers that that claim is a total fantasy. My important insistence here is that just good scientific conclusions are based on carefully taken experimental data and not based on speculative computer models, the old line, garbage in, garbage out. You don't know what's in the computer models. I accuse the IPPC and their contributors of being guilty of performing bad science and violating that tenet, and for dishonestly fudging the data. And I will show you, just in case you doubt me, I will show you exactly where the numbers are fudged and duplicating their graphs. The whole data program is woeful. The reason for a lot of this was that the whole data collection program was terribly underfunded, very unrealistic deadlines. It's a lot harder to measure stuff than you would expect. Most experimentalists themselves realize, well, you make your worst possible estimates, you multiply by pi. That's how long it will really take you. The experiments were very poorly designed, poorly executed, and when unexpected data came up halfway through, they just simply ignored it. And I'll show you that the lack of experimental data led them to just simply make up their own data. And ignore, since they couldn't explain the data that they didn't understand, they just simply ignored it. So they simply fabricated much of the data. They're made to match predetermined computer simulated conclusions, and they assumed flawed physics, and they kept coming up with the same result, 0.7 watts per square meter power imbalance. I will show you where that comes from and how it has been used. And most recently, it has been used to forcibly recalibrate all of the satellite data in the public database, so that if you go back and reanalyze it, it now shows what they wanted to show, but it was simply been rewritten. Show you that the computer simulations never get anywhere near the reality. There are wild divergences among computational models made at 20 different laboratories worldwide. There's virtually no consensus among the results from those 20 different laboratories, or even among the various models calculated within the same laboratory. And there is no agreement with the experimentally observed data. The observational data are all, from as far as I can tell, are fully consistent with zero global warming, zero climate change, and other than what is normally exhibited to just normal random weather problems. There is no demonstrable global warming or climate change, and certainly no crisis. Okay. What did they do during all this time? The IPPC and its collaborators were tasked to use computer modeling and observational data from satellites, ocean bathythermography, global network of surface radiation measurements to determine some very important numbers. The Earth's most important of these is, let's see, did I? Yes, okay. To measure the Earth's so-called power or energy imbalance, and thereby to prove their assertion that there is global warming. The global average temperature history, the identification of what are the dominant processes. They misidentified those as being due to CO2. And the last one is to analyze the naturally occurring feedback mechanisms that stabilize the Earth. The Earth's climate exhibits, given the various fluctuations, perturbations, external perturbations, the Earth's climate exhibits incredible stability. The real question is, why is it so stable, not why is it unstable? Or is it unstable? Okay, I assert that they have botched all these efforts in claiming that there's global warming when there is none. And their whole argument leads then to claims of an impending crisis. I assert that the claims are all bogus. Instead, I believe I have identified what the dominant process is, and it strongly stabilizes the climate. Okay, so they have built what I call a total house of cards. They claim that the global power imbalance and it produces global warming, and they have assembled this house of cards that forebodes this total crisis. Okay. How does this house of cards work? They have dishonestly claimed they have observed a power imbalance in the Earth's radiation budget, and that proves we have global warming. And if true, then the house of cards consists of this leads to climate change. Climate change in turn leads to an increased frequency of extreme weather events. The NOAA, National Oceanographic and Atmospheric Administration, dishonestly claims, and that's the first thing I will debunk, dishonestly claims to have actually observed an increase in frequency. And they repeatedly insist that there's a power imbalance of a net buildup of 0.7 plus or minus 0.02 watts per square meter power imbalance. And they assert that is caused by a buildup of greenhouse gases, especially CO2. And that gives you a so-called radiative forcing power of about 2 watts per square. And then the final conclusion is we need to spend trillions of dollars to fix it. Okay, I assert that that's not true. The IPPC has not observed net power imbalance. They have not proven global warming. NOAA has not observed an increased frequency of extreme weather events. Without a power imbalance, there's no global warming and there's no crisis. The house of cards collapses. And you no longer need to worry about CO2, and you don't need to waste trillions of dollars. Okay. First, this part has to do with the computer modeling. it's very clear that it's using very flawed physics. It's totally incapable of simulating global warming. All the simulations are in violent disagreement with each other and with the observed data. The CMIP5 family of results, these have been generated at 20 different laboratories around the world, and they all show a total lack of consensus among their own predictions. And I'll show you where their claims for power imbalance are based on totally fudged data. They repeatedly assert there is this 0.7 watts per square meter power imbalance, and that shows up so often, over and over and over again, that I give it a name. It is the Hansen, Loeb, Stevens, Vild, Pad, Penny. It keeps showing up over and over again. Okay. Hey, first off, we have totally insufficient data to measure this. The upper figure is the GISS temp map of available weather stations for 71 to 2000. That comes from Goddard Institute for Space Studies. This lower map is the list of the locations of the BSR and the baseline surface radiation network that was used by Vild et al. In 2015. First thing to notice is that where are all these stations? Well, there are a lot of them in Europe, a lot of them in China, the United States. But the important thing is the oceans cover 71% of the Earth's surface. This is where the action is. This is where all the weather is generated, where everything that controls the climate is generated. And in 2015, when Will had to write his IPPC contribution, he had a total of 6 weather stations in the oceans, and one of these was in the mouth of Chesapeake Bay near Baltimore, and so it was hardly surrounded, so the list is only 5. Okay. So they had, since they didn't really have any data, they just had to guess. Okay. Additionally, there was what was planned, this was Hansen's big argument, was the Argo buoy chain. Before then, temperatures were measured basically by a navigator on a ship throwing a bucket over the side, hauling it up and sticking a thermometer in it and writing it down in his log. And they was, of course, all following in the same sea lane, so he's getting all the warm, cooling water from the previous ship that passed. And very narrow, very poor coverage of the oceans. Okay, in 2016, Johnson, Lyman, and Loeb, 2016, long after all of these original claims were made, that they first say that it is imperative to improve the coverage of the Argo buoy chain. If supported, which it never was, it will make Argo totally global, continued, and coupled with satellite observations will allow us to monitor changes in the Earth's energy imbalance. Okay, and which is well known to be 0.7 plus or minus 0.2, 0.1, actually. Despite that very poor limited coverage, Loeb et al. Just simply took this number. They used, and that was actually based on a very sparse set of measurements that were measured before 2009. And they still didn't have any better data at that point. And they just simply used that number to override the Terra and Aqua satellite observational data and recalibrated them all just to match that number. So that any data you extract from their data, the public database is called EBAF, Energy Balanced, and something or other, is going to be biased by lobes, just simply recalibrating everything. That's part of the bad penny. Okay. If you try to read any of the literature, everybody keeps using this phrase, temperature anomaly. Actually, they use anomalies for everything. This is the worst piece of bad science I've ever seen in my life. Okay. There's no reference point. So you just see an anomaly sort of the zero level somewhere, and some is plus and some is minus, and they never report what the actual value was. So if you want to compare two reports, you can't, because you don't know what they all have different actual value. Okay, and they do that not just for temperature. They did it for most of the other quantities, and so it's totally useless without knowing to the reader to know what they actually measure. For example, if you want to use the seven Boltzmann law to calculate how much radiated heat you get, you can't, because you don't know what the actual temperature was. It's a way of hiding their cheats. Okay, but they did early on admit that measuring with the sparse data sets, measuring temperature was difficult. They needed a better definition. You only get one definition, and everything else is reference to it. And so what the primary workers did was they said that this is the definition of global warming is if there is a global power imbalance. Actually, they said they call that Earth's energy imbalance, whatever, and they abbreviated it EEI, is their jargon that they used. Okay, what is meant by the power imbalance or energy imbalance? It's a very simple idea. If you have more power coming in, more energy flowing into the Earth in the form of sunlight, then is flowing out, there is a net buildup. It's Gauss's law, effectively. So what flows out is you reflect some of the sunlight, and you just re-radiate some heat, thermal radiation. And the difference between the power flowing in and power flowing out is the imbalance. They also, just to make it more confusing, they add a new piece of jargon. They call sunlight, everybody knows what that is. No, that's shortwave SW radiation. And the far infrared heat, they call LW radiation, long wave, just to confuse you. Okay. Cuts down on arguments, they say. Yeah, because nobody can understand you. Okay, so like I say, conservation of energy says if you got more coming in than you're flowing out, you get a buildup, and that's the power imbalance. It is readily calculated from what's in theory supposed to be observed satellite data. And to be believable, all these numbers should have been measured, not just something you calculated or simulated in your computer code. Okay, and again, to be a careful definition, you need to specify where all of this power is flowing in and out. And by convention, this is called the top of atmosphere. Unfortunately, they don't always obey their own rules. And the power flow diagrams don't even ever tell you where they get their data. Now, here is a typical power column. This is from the 2021 AR6 assessment report, from page 934, if you look for it. Okay, they give you two power flow diagrams. Okay, and the power flowing in, here is the incoming power, 340 watts. These are numbers pretty easy to remember. About 100 flowing reflected, and 240 or so. Now they use this very strange notation that was invented by Wild et al., where they just put the error bounds in parentheses. This is a total no-no. Now you'd assume that these were measured values. Bad assumption. They lie. Okay, you'll notice that here I have two diagrams, all sky and clear sky. Where did that come from? Ramanathan in 1987 decided that it was easier to analyze the power flow of the atmosphere by dividing up into two, in theory, homogeneous portions, which he called clear sky and cloudy sky. And the average, the area weighted average of the two is what we call all sky. There's a third diagram, I mentioned cloudy sky. The IPPC literature, also just to make it confusing, they call that the CRE, or the cloud radiative effect, which means it's the difference between the two. Anyway, so basically he assumed that we could divide these up, that the whole sky could be divided up into these two portions. And he also assumed that that was a necessary and sufficient condition for understanding the climate. Okay, this convention has been persisted ever since. There are difficulties with it, however. He set this up after some very preliminary analysis. Only four months worth of data, 3 months apart around the calendar, assuming that everything is that followed a sinusoidal dependence in time. It doesn't. And he was using a very early, not very good satellite, the Iribi satellite, the radiometry data from that. And he admitted, yes, this is all preliminary. And he assumed that subsequent satellite projects would allow more accurately and more completely to do the cloudy, to measure the cloudy sky and clear sky components. Okay, there's a problem also with the cloudy sky is it's dependent upon the resolution of what you see when you're looking down. The Iribi satellite, or what the reports are all averaging over 1 degree, not even square area elements, 1 degree longitude and 1 degree latitude. Well, that's a trapezoidal box when you get closer to the poles. Okay. Unfortunately, his expectation was never fulfilled. As of 2021, no such satellite measurements had ever been performed. Along the way, however, King et al., King was at the University of Colorado, observed a very different behavior. I'll show you that next. That showed that you can't do it with just two. You really need to have 4 separate regimes. And they used 13 years continuous observations from the Terra and Aqua satellites. 2 years later, Bill et al. Attempted to analyze 2-component atmosphere with ocean and land being the 2 partitions. The results were disastrous. I mean, the numbers are really silly. I'll show you those. Okay. So Bill et al. Realized, I guess, that kind of botched that one. So then they redid their analysis in 2019, and they reverted to Ramanathan's original clear and cloudy sky partitions, and that was adopted by the IPPC's AR6 assessment report. To show you that in fact it is straightforward to build a 4-component model. I'll also show you, but King's discovery was totally ignored. That was a very big mistake. Okay, King et al. Discovered need for 4 partitions. That is vitally important, and nobody paid any attention. Okay, they analyzed 13 years worth of data, and here's what they found. It's really trying to amazing. They independently looked at the ocean and at the land. Remember, the ocean, that's 71% of the Earth. And they looked at what is the cloud cover fraction. You don't need to have an absolute calibration. All you need to do is just count pixels. How many pixels have clouds in them and how many don't? So it's a straightforward averaging. And they found that the average cloud cover over the ocean is about 72%. The average cloud cover is over land is only 54%. And this is just, they just showed published the daytime. Okay, but it shows that land and ocean are very different, and that these are all temporally oscillating. These are what gives you seasons. Okay, the blue curve in the middle is the average, the weighted average. Okay, so we have these 4 different regions: cloudy over land, cloudy over ocean, clear sky over land, clear sky over ocean. And each one has its own albedo. What's albedo? That's just simply the reflectivity. If you sit in sunlight, what fraction of it reflects back out into space? If it goes back out into space, it can't heat the Earth anymore. Okay. So 55% over land, 72% over the ocean. The daytime average is 67%. Everybody else agrees with 67%, but nobody pays attention to this land versus ocean difference. Okay, I have added a power scale here just by simply multiplying by the power coming in. And from their reports, you can calculate what they think the reflectivity fraction of clouds is. And I just use the numbers out of that were in the IPPC report, and that gives you this is the shortwave power that's going on. So we're getting typically over the ocean 105 watts per square meter. Over the land, only about 90 watts. But the land is much smaller, and there's a lot more of it in the northern hemisphere than there is in the southern hemisphere. Okay, and I'll show you, I've got appendices in the slides, which I won't go through, but just show you how I got the numbers. Okay, so you can see that there is this quasi systematic temporal fluctuation, seasonal, for both land and ocean. It's oscillating, the average is oscillating by about 5 watts. Subsequently, Stevens et al., ignoring the land-ocean difference, just so for the total combined, found also this systematic oscillation. Didn't understand it, didn't use it. But this, I think, tells you a lot about the important physics about how the climate works. Another thing which this does not show is that this variation here of only about 5 watts for combined is actually much smaller than the actual change in the reflected power, because this gets combined with the fact that the Earth's orbital radius is not the same. The Earth is in an elliptical orbit, and I'll show you that later, and that adds and changes the actual power. Okay, Stevens, I mentioned Stevens found this to be true. He didn't associate it with cloud fraction oscillations, but if you look at the two curves together, you see that the reason that we have the oscillation in the Earth's albedo is due to the fact that the cloud fraction itself is oscillating. Okay, and there's a huge change for clouds. Okay, clouds, at least in the Pacific Ocean, is half the Earth. Those clouds, at least for North America, where I'm a little bit more familiar with weather, they drift from the ocean onto the North American continent and produce virtually all of its weather. So a cloud drifting from land to ocean has a power output change of 23 watts per square meter. Nobody seems to pay attention to that. Okay. You'll notice, okay, the dotted lines here is the Aqua satellite, and the solid line is the Terra satellite. You'll notice there's a huge difference between the two. They're in exactly the same orbit in opposite directions, and the altitude is such that they orbit once every day. And so the Terra passes over the equator at 10:30 in the morning, and Aqua passes over the equator at 1:30 in the afternoon. In that 3 hours, there's a typical 3 to 5 watts per square meter change just in 3 hours. So this is a very rapid process. Okay, the important thing that they didn't notice is that this cloud fraction modulates very strongly the outgoing sunlight power. Clouds are very reflective. They're bright white. For example, that clearly determines this oscillation is seasonal, is clearly determining the winter-summer temperature difference. Stevens et al. Was totally oblivious to this. There are new questions. I'll skip that. Let me just move on first to my assertion that the most easy part to debunk here was Noah's assertion that they have observed an increased frequency of extreme weather events. This was done in a Physics Today article by two politicians, not scientists, Jane Lubchenco and Thomas Karl. Jane Lubchenco is Undersecretary of Commerce, the Department of, and Karl is Director of NOAA's Climate Science Prediction. And they assert here that it is obvious that destructive weather is growing more prevalent. And in the text, they say this is very obviously occurring in the last 3 decades. Okay, it was published in 2012, and what they plotted in their data. Now, if the director of the climate program and the Undersecretary of Commerce cannot get the very best data available from NOAA, nobody can. So I think you have to believe that their data are believable. What do they plot? They plot a climate extremes index. Okay, it is a composite mixture of what they call various extreme weather events, frequency of hot spells, cold spells, droughts, floods, landfalling hurricanes, you name it. Well, you can't name EF3 plus tornadoes because they left those out because, as Steve Koonin points out in his recent book, they're actually decreasing. That would bias the data, so they wouldn't want to use that. So anyway, Lutsenko and Carl claim that the index has obviously grown over the last 3 decades. Here is the graph from their of the Physics Today article of their climate extremes index. Here are the things they use: landfalling, soil water surplus, days without precipitation, etc. When I was at Dell, Alvarez would look at that and say, "Finest line I ever saw." Okay, so the way I would like to debunk this, I just took a pet transfer and I traced those data points right out of the Physics Today article. And I made 2 of them. I traced them on transparency, and then I flipped one of them 180 degrees. So this is 100 years worth of data, one data point for every year of the climate extreme index. And so one of these graphs, time is going backwards. And one of it, how many people here think it's the left one that time is plotted correctly, and how many think it's the right one? Are you willing to bet trillions of dollars that it's, you're making the right guess? I assert that you can't tell the difference. So it's pretty obvious they're mirror images of each other. But if you can't tell the difference, I assert they have not proven their point. Okay. Let me move on to the computer modeling. This was done mostly, I think, they never really said in the articles I could find who actually wrote the computer modeling studies. Mostly it was done at Goddard Institute for Space Studies. And it is used by a wide variety of more than 20 laboratories worldwide. And apparently mostly the input and outputs are juggled by whoever's using the program. There's a total disarray and lack of reliability in the predictions from the CMET5. And I'm not the first to notice this. Steve Koonin, in his recent book, Unsettled, also noticed that they are all in disagreement. And Gavin Schmidt, who is the director of Goddard Institute following Jim Hansen, published an article recently where he says, we can't really understand this using our models. Okay, these are from Bill et al. 2015 paper. Each bar in each of these graphs is a different laboratory and/or model's prediction. Okay, the first one is all sky over land, sunlight moving down, as in sunlight up minus reflected, minus absorbed, you actually going down. This should be something that ideally the satellites could measure. And each of these are the variations they got from the various calculations by the computer simulations. They're gross disagreement. The values are ranging by 41 watts per square meter. Okay, and the power map value says 184 and only a 5 watt per square meter range of uncertainty. With no simulations, how can they possibly say it's only a 5 watt? Okay, here, this is one that's really weird. They say here's the all sky top of the atmosphere, heat re-radiated. Okay, and here is where they put on the power flow diagram their 2 sigma error bar limit, and all the simulations are way below that. And they say, well, that's the 95% confidence level. There are only 2 simulations that got into the error bar. And the thing is so silly that they have their reported value on the power flow diagram is outside their own error bounds. And the same thing here. Okay, so when they redid this in 2019 using clear sky and cloudy sky, again, they had huge simulations, 37 models. So I would say this is anything but consensus. Al Gore would tell you, oh, we have total consensus among all the climate scientists worldwide. If we had consensus, they would all calculate the same number. Okay, so what else? Okay, they're totally incapable of compared to actually observed experimental data. They can't even get the temperature history right. They can't get anywhere near the total albedo right. Okay, and I assert that this total disarray indicates that there is flawed physics. Okay, this graph was printed on the back page of the American Physical Society News. Okay, the colored lines are predictions. The gray lines are all these different models. They have 40 different models shown here. The heavy solid black line is the actual temperature history. There's not one model that can predict, that can agree with the data. So this indicates to me, as an experimental physicist, that there's something wrong with the models. The physics is incorrect. It's also incapable of explaining the Earth's albedo. That's the reflectivity of sunlight. And serious discrepancies. And here the bad physics really comes out. This was published by Stevens et al. In 2015. The black line is the actual satellite data. Notice it's a non-sinusoidal curve. This is the 10-year average, showing that yes, there is a highly systematic fluctuation, and this is just matches, right, as far as I could tell, King et al.'s cloud fraction, annual cloud fraction. What are all these yellow colored curves? These colored curves are let's see, the colored curves are the CMIP5 simulations. They're all totally incapable of explaining the experimental data. The IPPC does not, any of the AR assessment reports will not show this very embarrassing figure. Okay. Again, I can do the same thing that I did on the King scale, multiply the albedo that they're measuring by the incoming power, and it shows that the albedo itself, fluctuation, causes 10 watts oscillation in the reflected power. Okay, and the error in the CMIP5 calculations is more than 10 to 15 watts. They can't even get the phase right of the oscillation. Nonetheless, the IPPC's assessment reports still report that we know the power imbalance to 0.7 watts to plus or minus 0.2 watts. Okay. You remember I mentioned that the Earth's orbit is highly elliptic. So the actual, here they're reporting anomalies, my favorite. Okay, and this is the actual sunlight that's falling on the Earth just because of the ellipticity of the orbit. And that adds another 22 watts of fluctuation in the actual reflected sunlight power. So that the total outgoing power is fluctuating by 31 watts per square meter. Okay. Yes. Okay. I already mentioned these. Okay, and what this shows, when you compare them, is that the cloud fraction. Clouds are very reflective. They're bright white when you look at them from space. You look at any of the satellite pictures. You see nearly black oceans, and you see bright white clouds. So you can kind of ignore everything else. This is where most of the sunlight all is getting reflected. These are the big numbers that have been totally ignored. And they show that the cloud fraction oscillations, the systematic oscillations and the daily oscillations, highly modulate the outgoing sunlight power. Oh, and it's huge. Okay, so did they actually try to measure this? Well, yes, they launched a bunch of satellites. They used a whole bunch of methods to actually measure the data. There was the Aribi satellite, Earth's radiation balance experiment, Nimbus, Terra, and Aqua. The ocean heat content was measured using both the Argo buoy chain and this water sampling by ships. And finally, by using this baseline surface radiation network, that was the earlier map I showed you, the lower one with all the little green and red triangles. Okay, various measured values between the ocean heat content measurements and the satellite are in violent disagreement. Get into that in a minute. And there are huge gaps in the data. Things break down. And we didn't install all the buoys, etc. So what are you going to do? Just make the data up. And okay, now if you're an experimentalist, you will probably have heard of the Shannon-Nyquist sampling theorem, which tells you how many points you need to do to actually measure all of this. We're nowhere near that requirement. Okay, fabricating data is one of our little no-nos in science. Nonetheless, it is used. Lyman and Johnson, in particular, readily admit the fact, and they write long articles exactly of how they fabricated the data. And they're very proud of their methodology. But so if you run out of time when you're doing all this experiment and you got to write a report, what do you do if you don't have enough data? You just simply make it up. Okay, and the data, what do you use for criterion? They totally fudge this in a manner that dishonestly shows shifts from showing no warming to showing warming. They call this procedure adjusting the data. And they even admit they do it because they don't like the results they see. Measuring should be easy, one would think. At least the theorists who set the whole plan up did. You just measure the power going in, you measure the power going out, and you subtract. What could possibly go wrong? Doing experimental science is a lot tougher than it looks, especially if you don't have enough money, and nobody ever does. And when you have an unrealistic schedule on when you need to deliver the results. Okay. Remember the definition is more power coming in than power going out. Okay. And I also mentioned that the solar constant is not actually constant. It's a misnomer. It varies. Okay. The power going out has got the two components: the sunlight coming in, or that is directly then reflected back out into space. That's claimed to be about 100 watts. The heat radiated is about 240 watts. Okay. The problem facing the experimenter is that these are huge numbers compared to the difference. So that an error in any one of these three numbers totally screws up the measurement that you're doing. It's only about 0.2% of the incident sunlight power. Okay, so and worse yet, all of these powers, especially the reflected power, because of clouds change or continuously changing, and they are irreproducible. So it's hugely varying, and there's no way to measure this accurately. And even the observers, Hansen, Stevens, Loeb, Lecoyer, all admit that the radiation, the satellite data methods are totally incapable of determining the power balance to the required accuracy. They admit that it's impossible with the tools they've got. Okay, so in theory, what's reported on the IPPC reports, the assessment reports, and the contributors' reports are the three important numbers. And I mentioned that the convention is this is all reported at the top of the atmosphere. Unfortunately, since you can't really do it, they admit, well, we can't really do it with satellites. That's how you know a place to look for it. So Hansen says, well, we're going to kind of ignore this cumbersome detail, and we're going to mix up surface data and satellite data. Okay. So usually when they don't have data, they just simply computer simulate it and plug that in. And so what you see written on the power flow diagrams, if you carefully read through the text, say, well, yeah, we did calculate that one. Okay. Who's responsible for all this? Hard to say. But it got so bad, Stevens and Lecoyer, okay, had got different results. And they even wrote a mea culpa article saying, yeah, we did fudge the data. And yeah, we had no reason for the choices we made. I'll show you that paper in a minute. And I mentioned all of this has had contaminated the publicly available data. And I'll show you exactly where the numbers are. So if you don't believe my claims of fudging, you can do the simple subtraction yourself. Okay, so here's what they admit. Well, we can't really do it. A limitation of the satellite's lobe et al. 2012. Limitation of the satellite data is the inability to provide an absolute measure of the net top of atmosphere radiation imbalance to the required accuracy level. We're dead, he says. Okay, so they just simply fudge the numbers. And they admit this of the satellite data, and they just switch modality to use the ocean data. That's because Hansen told them to, as far as I can tell. Okay, worse yet, Nobel et al. In 2018 go back through and they recalibrated the database to match the ocean heat content data. He doesn't admit the mea culpa that Stevens and Coulier do. Okay, so calculation is pretty simple. You just take the top number, 340, subtract 100, subtract the 240, and you get the imbalance. Okay, how do you calculate the error bar? The standard method is that it's the RMS sum of the individual error bars on any one of these articles. Okay, there's an immediate cross-check that you can look at, just it should immediately catch your attention, is if the imbalance error is smaller than any one of the component errors. That is impossible with the standard formula. And so if it's outside the error bar, they say there's global warming. It's not, it is. Here's the data. Here's a table of it. I'll try to go through these. It started in 1981, whole series of contributions, and the numbers all of a sudden here in 2012, all of a sudden start getting the same number, 0.6 watts imbalance. It keeps getting plugged in over and over and over again. So this isn't just an accident. This is done intentionally. Okay, here's 1981, Stevens et al. Okay, here's his summation, their summation. And then here he was not yet into the fudging. Ramanathan, he was the guy who did the partitioning, remember? He looked at that and he says, well, as far as I can tell, it's all zero. Here's his power flow diagram, similar to this. Well, the National Academy looked at this in their 2003 report and said the observations do not meet quality standards. Okay, now here's where things start to get dodgy. Loeb et al. 2009 and 2012 used the ocean heat content data to adjust the numbers that Ramanathan had on the Rebi and Nimbus satellite data. And they just simply say, we're going to shift the values to give a new power imbalance. That's one of our little no-nos. You can't do that. You can't say what it is you measure if you're a decent scientist. They got the values from the ocean heat content data, and the Argo buoy chain, which we already mentioned, was totally incomplete. And it was Hansen, where'd I go? Hansen, who apparently put him up to it, as far as I can tell. Okay. So, and here's where the arithmetic starts to get dodgy. This is low at all. Again, okay, if you add these numbers up, you get minus 1.6 from the satellite data, 2009. You get plus 0.09 here. But then in 2012, he says, nope, it's just 0.6, plus or minus 0.1. That's the bad penny, first appearance. Okay. Stevens, okay. Loeb et al. And Stevens et al. Had two groups. They merged together and they admit the satellite, both admit satellite data are insufficient, so we got to bring in do something else. Okay. And so and they say, well, we can shift it. Data, we call it adjustment. I call it fudging. Okay, and here is their summation. If you add these numbers, you get plus 0.5, plus or minus 3.9. They can't even do the sum right. And they say what they report is 0.6 plus or minus 0.4. Okay, and here is their diagram. If you don't believe me, there is that number, and this is the number, and this is just Xeroxed right out of their paper. Okay. This was the primary report of a global power imbalance that was adopted by the IPPC's fifth assessment report in 2013. And they admit that they fudged or adjusted the data. But they don't admit that they can't do arithmetic. But if you look at it, that cross-check, the error bars are much smaller than the error bars in the individual components. But they did relax the result. Okay, Lecuyer was one of the members of the team, Stevens et al. And Lowe. And so apparently he just couldn't handle the data fudging. And so he decided to write a minority report. And there's no data fudging evident in his 2015 diagram. He did admit to shifting the data he didn't exactly say why he did it, but they both showed no global warming. Here is their power flow diagram. Here is the incoming solar, the outgoing reflected solar, and the outgoing line. That's where I just got the numbers on the previous slide from. Okay, then two whistleblowers come along. There's a third one that joined them later in 2014, of all the state of Trenberth and Vasulo. Okay, they noticed that, you're mixing up altitudes. You can't, this is one of our little no-nos. We got to maintain constant altitude because you got to know what's going on in between the top of the altitude and the surface if you're going to mix up some of these numbers. They are very critical of Loeb, Stevens, Lecuyer, and Hansen's claim of understanding what's going on in between. They call this, by the way, this is called closure of the power balance. Okay, and they point out that there's this huge energy missing. Okay, Hansen responds, and he says, it's just a calibration error of the satellites. Though curiously, King et al. Did not experience this satellite calibration, and there are still unresolved discrepancies in Henberg, Vasulo, and Balaceda. But these are the original whistleblowers. And here's the graph from Henberg and Vasulo. And in 2005, all of a sudden, there's this huge missing energy. And you can't explain it just by melting polar ice caps. And you can't explain it all of a sudden starting in 2005 that Stevens tries to do when he recalibrated and fudged all the data in the public database. Okay, so now we have an open war, Stevens and LeCoullier, and there's a lot of severe public criticism by Stevens. Okay, so Stevens and LeCoullier co-authored their mea culpa article. They admit to the data fudging and admit to having made an unjustified ad hoc choice between the two data sets. Okay, so they join forces and they admit to the adjustments, and they admit there's about the order of 10 watts per square meter. That's from their paper. But nonetheless, they say they're both right. In the line 5 of their abstract, they say, no, well, it's still 0.6 plus or minus 0.4. So they miraculously claim that both 0 and 0.4. So this is from the Stevens and LeCoullier mea culpa paper. This is the outgoing heat, incoming sunlight, and not reflected sunlight. They notice there are two lines here. One is satellites, and one is the ocean heat content. Okay, and here are their summations. Where they in the text is where they show, it's 0, but then in line 5 of the abstract they say, no, it's 0.6 plus or minus 0.4. Okay, then Wild et al. Okay, these are the first group are Americans, and now these are the European group. Wild et al.'s group did two of these reports in 2015 and 2019, and the 19 article was adopted by the IPPCs in their 6th assessment report. Okay. Okay, so that I mentioned that they decided you could shift the reported value within the error limits. It's a very dodgy trick. If you do that, you don't know whether or not you're shifting correctly. So you really need to add that uncertainty to the final uncertainty limit. They reduce the uncertainty when they claim that. But now we get to the really dodgy trick, where they have a new method of reporting error limits. Normally, you would report 340 plus or minus 0.1. This is the kind of the standard method that most scientists use. So instead, they would report 340, and then they would say 340 and 341 in parentheses. It's their error bounds, and report various values. Okay. Now they notice what they did that's really dodgy. Notice these are all values here good to the whole watt per square meter. The difference they get is a fraction of a watt. How do you get a fraction of a watt by summing numbers that are whole numbers? Well, the round-off error is about, for each one of these round-offs, is about 0.5. And that's the value of the total value of they found in their imbalance. Okay, so here's where it really gets silly. This is Wild et al. 2015. They decided, well, maybe I have no idea whether they were trying to mimic King et al. But they decided they were going to partition differently, sea and land. And here's that one I showed earlier. They have 232 watts here, and the error limits are 236 to 242. The really weird one is, look at the sunlight. Sunlight coming in over the ocean is 347 watts. Over the land is only 325 watts. Okay, so somehow, so we have 347 here, 325 for their two independent. Again, they can't even do arithmetic correctly. They report an imbalance of 0.8, the bad penny. They got to do that apparently. And this 232 was outside of their own errors. And here, but they even noticed this fact. Amazingly, with great certainty, they noticed that they require the sun is 22 watts per square meter brighter on the ocean than it is on the land. And this is a direct quote from their paper. As noted above and evident from figure 2, the surface downward solar fluxes averaged over land and oceans are nearly identical, which seems a robust feature in our estimates, see section 2. This is the case despite an insolation at the top of the atmosphere, which is higher by 22 watts over the ocean than over land. They believe their own bullshit. Okay, so here's their power balance for the sum. Again, they can't do the arithmetic correctly, and they use this dodgy result, and they just forcibly stuff in the bad penny. Okay, now here's what I call the smoking gun on all of this. This is Loeb et al. In 2018. Whoops. Where did I go? Loeb et al. In 2018. Loeb and Cato has also been a comment. And these are their, okay, they actually did this twice. This is the EBAF is the energy balanced and filled top of atmosphere addition for data product. So if you want to ask the government for data, here's where they go, and here's where it's not unadjusted and with their constraints on these columns. And so here are their adjustments, where and the result at the end is they stuff in the bad penny. They force this to agree with what Hansen told them it had to be. Okay, and this is they were using this. He based it on Johnson, Lohmann, and Loeb, which a priori assumed green gas. Admitted the very first sentence of their paper, they know that for sure the greenhouse gases are causing global warming, and all that they admit that their data are way too sparse, but nonetheless. A previous version of the subjective constrainment algorithm described in Loeb 2009. Total annual values are adjusted, so the mean top of the atmosphere flux is 0.7 watts. Okay. Okay. So then, since that was such a disaster, they got called back to do it again, but now use Ramanathan's method in 2019. Okay, and again, they do the same fudging. They have a clear sky and a cloud-free sky, and they use ground sunlight observations from the baseline surface radiation network. Okay, so again, they're using cloudy and clear sky and the CRE. Okay. There's another error in there that maybe if I have time, I'll get to it. So here is their power flow diagram, 340, 100, 239. And notice all of these are whole numbers, and here they get 0.6 as the difference on the cloudy sky. Now, important thing to notice on all of this, well, I'll get to it in a minute. Okay, so here are their numbers. And here's their dodgy method of reporting error bars. And again, these are the arithmetic that I do, and they report. They can't even do the arithmetic right. They get 0.6. And so this was the primary reference used by IPPC's sixth assessment report. And here it is. I showed you this picture earlier. This is the all sky, the clear sky. Notice this huge amount of power coming here of the ocean. That is the total amount of energy used for evaporating water. That's all it's doing. Okay, so this is that power flow diagram. And again, we have, if I add up these numbers, I get 2.5 showing no warming. They say the sum is 0.7. You just can't, I mean, that bad or they get really bad. And again, they're using this dodgy method of reporting error bars. Okay, I'll go through this rather quickly just to show that it can be done, even though Build It All 2015 couldn't do it. You can do a four-component arithmetically correct power flow diagram, especially on the sunlight power, which that is consistent with all the observational data. If you're allowed to just sort of pick your own albedo values, consistent with what observational data shows, and it's consistent with zero power imbalance. You have to pay attention to the fact that all these processes occur at different altitudes, and you need to calculate how much it occurs at each altitude, and you have to use area correct partitions. Okay, one of the things that nobody pays attention is a major part of what you see when you look at reflected sunlight is blue sky. You look up, Daddy, why is the blue sky? Well, because this Lord really discovered that scattering of sunlight by nitrogen in the atmosphere gives you the blue glow. That's all at very high altitudes. The absorption by ozone is all occurring up in the stratosphere. Okay, airplanes are flying around here, 30,000 feet here, and all the clouds are all down here at very low altitudes in the troposphere. So if you pay attention to all of that, plug in reasonable numbers, you had to notice that the albedo you measure from an airplane is very different from the albedo you would measure from a satellite because you have added blue sky, rayleigh scattering, and you have additional absorption. But so if you go to Wikipedia and say, well, what are the albedos of various items? And you could, so I just picked values that are consistent with what Wikipedia thought. And so and you can have a lot of degrees freedom so you can readjust. You'll notice these are kind of area weighted. Most of the sunlight that gets reflected is all coming from clouds over oceans. Because the oceans are huge and the clouds are bright white. Okay. What are other important things? When a cloud flies over, it casts a dark shadow. Just look down when you're landing in an airplane, and you can see below you there's really sharply defined shadows. When you're driving in the mountains, look down in the valley, and you see the shadows with very nice, clean, sharp boundaries on them. That's because, and where's all that light go? It gets reflected back out. Yeah. And you notice this if you look at the power output from your solar panels. Every time even a single solitary cloud passes over, you get at least 50% drop. You try to read a book indoors on an overcast day, you can't. It's too dark. You got to turn on the lights. Okay, so here, for example, is if you have a pyranometer on a cloudy day, every time a cloud passes, boom, the total, and looking up at the total power coming in from the blue sky and the sunlight, boom, and drops down to about 20% of the 34% of the power that was going out. Okay. So again, remember that I meant that huge power that was used for evaporating water. What does sunlight actually do when it comes to the Earth? Most people say, oh, it warms the Earth. Wrong. Maybe true over land, but that's only 29% of the Earth. 21% is the ocean. And so 71% of the sunlight is falling on the ocean. And that's according to that power flow diagram. We have 160 watts per square meter absorbed by the whole Earth. So 71% means 114 is absorbed by the oceans. And remember, we had 82 watts used for evaporating water. And remember, that power is strongly modulated by the cloud cover fraction, all being reflected back out into space. So that means 51% of the power, the input energy of the Earth is absorbed, is used initially not for warming the Earth, but just simply for making clouds. It's the world's biggest heat engine. Why do I concentrate on the ocean? Well, because that's where the exposed water is. There's no negligible. Okay, I'll move along quickly. All right. Okay. So, whoops, where did I go? Okay. So what I assert that the dominant climate control process is the cloud thermostat feedback mechanism. Okay, cloud thermostat works just like the thermostat in your house. It switches on and off. The on-off switching is done by clouds casting shadows. Locally, you have turned off the power, and that just stops the evaporation of water when you have a shadow. That stops the cloud formation. You had too few clouds, you start getting more. You have too many clouds, you start getting less. And that's the modulation has been observed. Oops. Okay. Okay. It's all. So let me mention this is a feedback. It's like you're throwing this out of your house. Okay, it's straightforward to calculate the strength of this. I won't go through the details, but I can done the calculation using the methods promoted by Sherwood et al. This is the standard reference that people use. And I assert that the IPPC has totally botched their identification and ignore this important process. Okay, so using Sherwood's method to calculate it, won't go through the calculation, the details, but it's straightforward to do this. And so here's the result of the calculation. I've got, okay, here, the graph is from AR6, page 979 of the strength of the various feedbacks. This is the net. This is this so-called Planck. Actually, it's misnamed. It really should be Stefan Boltzmann. Okay, here's what they consider the cloud feedback is destabilizing. You put in the effect of the cloud thermostat. This is the strength, the total strength of the cloud thermostat. It was strong, just dramatically 7 times bigger than anything they calculated before. So what are my conclusions? Great news. There's no climate crisis. Our planet is not in peril. Great news. CO2 is not a pollutant. CO2 is trivial results compared to the climate control stabilization by this cloud thermostat mechanism. Bad news. The IPPCs and those claims are a total hoax. Trillions of dollars are being wasted. They have dishonestly, IPPC has dishonestly cooked the books in order to claim global warming and climate change. The claims are false. They have not observed top of the atmosphere power imbalance. On the contrary, all of the observable evidence has been fudged. And I showed you just where. The house of cards has collapsed. The trillions of dollars are being wasted. And despite what Al Gore insisted, there is no scientific consensus. All of the various laboratories around the world calculate different numbers. His claims are a total fantasy. The total lack of agreement shows that, and it shows that there's total lack of consensus. Worse yet, the unresolved disputes between Hansen, Loeb, Stevens, Lecoyer, and Chenoweth and Masulo further indicate there's total lack of consensus. Okay, the computer simulations use bad physics. They get anywhere near agreement with data or with each other. They're all consistent with zero global warming, zero climate change, beyond that exhibited just by normal weather patterns. There's no demonstrable, okay, and NOAA's own data refute clearly their own claims of having observed climate change. This is done with dishonestly fudged data. And it's clear this isn't just an idle mistake. It occurs over 2 decades, over and over and over again with the same number being stuffed in. That is intentional fudging. And I lost it. Some of the workers even admit, yeah, we did fudge the data. Stevens, Loeb doesn't admit, he does admit to changing it, but he doesn't admit that it was dishonest. They admitted that they made a dishonest mistake. Okay? The other thing notes is 2 partitions are not enough. You need 4. King's discovery of this cloud oscillation, of 4 different areas is very important, and it has never been reported in any of the IPPC reports. Okay, let's see what else. Okay, and the observed oscillation that both King et al. And Stevens et al. I think are very strong support for this my cloud thermostat model. Okay, the important thing is that they have ignored the big numbers. The big numbers are the order of 70 watts, 320 watts change from when the cloud passes over and they're saying the most important thing is this 2 watts per square meter from CO2. So I've calculated the feedback strength and shows that it's by far the strongest there is. Okay, I've more than used up my time. I thank you for your patience.